standard meter. So there is a definition of a standard meter always either in college laboratory or in any other types of laboratory. Standard instruments are defined by some conventional principle. Right? So these instruments that we are using here, ammeter, voltmeter, wattmeters in our labs, these are basically called secondary instruments. Right, secondary instruments. So secondary instruments are different from the standard instruments. So always these secondary instruments must be calibrated by using the standard instruments, or they must be calibrated by using another type of calibrated secondary instrument. Okay. Now we generally do this calibration to check the accuracy. We generally do this calibration to identify the errors. It may be a parallax error, it may be any observational error, it may be any unknown error. Okay, so there are many types of errors in the measurement of different types of parameters like voltage, current, and power. So, calibration is highly required to check all these factors. Okay, suppose, for example, to perform a particular experiment, you have chosen a standard fixed voltage, a set voltage at 100 volt. Okay, and you have taken 5 or 6 readings, and those 5 readings are very close to 100. Like one is 100.3, one is 100.4, one is 100.1, one is 100.01, one is 99.99. Right, you have got these data with the standard or set voltage data at 100 volt. That means all the readings are that you have got from the experimental results, all are close to the set value. Set value is generally named as the true value or the standard value. So, and all these observed data, the measured data from the experiment is are called the test data or test reading, right? Now, if these test readings or test data are close to each other, then we say that all the readings, all the data are precise. And if these data are close to the true data or the standard data, we say that the uh, accuracy is good, or we can say that the percentage error is less, because you can see the percentage error formula is test data minus true data divided by the true data into 100. So if there is any deviation from the standard reading or true data, it will be termed as error. Right now, to check, to identify this error, always we need to check the test readings or test data, how far they are deviated from the, how much they are deviated from the true data, or how they are close to each other. Like for 100 volt, one data is 99, one data is 90, one data is 110, one is at 120, right? That means all the data are uh, not close to each other, and they are not close to the true value or the standard value. That means the readings are neither precise nor accurate, right? Now, in order to reduce this error, always we need to check whether the instruments are properly calibrated or not. So because of these reasons, always before using of any instruments in any circuit, always it is to be calibrated by using a standard experiment. So here in experiment 3, we'll see how an ammeter and wattmeter can be calibrated by using voltmeter and ammeter, which is standard type. So this is the circuit diagram for the calibration of wattmeter. This one is the test wattmeter. This is the circuit, that means this is the AC side, single phase to 30 volt 50 hertz AC supply. This is fuse. This is the variac, single phase variac, which is just an auto transformer. So we have seen the use of this variac in the previous experiment. So by using this variac, we'll be able to vary the supply voltage, the AC supply voltage. This is the voltmeter connected in parallel with the variac, is used to measure the supply voltage, and this is the ammeter, which is connected in series with the circuit to measure the source current or the supply current. And it is required always to connect the ammeter in series with the circuit, in series with the main circuit, and voltmeter in parallel with the supply side, right? Because what is the internal resistance of ammeter? What is the internal resistance of the ammeter? It is 0. The internal resistance of the ammeter is 0. And what is the internal resistance of the voltmeter? Ideally, it
It is
is
also
infinity. Practically, it is very, very high. Okay. So because of these,
yes, ma'am.
always we connect ammeter in series with the circuit so that maximum current can flow because the resistance is 0, and always we connect voltmeter in parallel with the circuit because of its high or infinite resistance within it. And this is the wattmeter to be connected in series with the circuit always. It has got 4 terminals. M stands for main, L stands for load, V stands for voltage, and C stands for common. And it is required to join these 2 terminals, M and C, always at a common point. They must be shorted always. And M will be always connected with the main side, means the supply side, and L should be always connected to the load side. Here, load is a bulb load, which is connected with this wattmeter in series via a switch. Right? That means whenever this switch is closed, the circuit will be closed, and this wattmeter and this ammeter will be connected with the load. Okay. So this is the required circuit diagram for the wattmeter calibration, because what we'll do after switching on the circuit, will vary the supply voltage, and with the variation of supply voltage, this voltmeter and ammeter readings will be varying, and definitely wattmeter will read some values, and this wattmeter will give the test values of wattage, and uh, these 2 meters, that means the readings of these 2 meters, voltmeters and ammeters, will give you the value of the input wattage value, the input power, right? That is the standard one, standard value, because these 2 meters are standard meters, these the 2 instruments, VS and A. VS means the voltmeter, mainly voltmeter denoted by this symbol V, and ammeter denoted by this symbol E. Okay. So with this test value and the standard value, we can calculate the error, the percentage error. And this is the circuit diagram for the calibration of an ammeter. See here, another ammeter is connected. Wattmeter is not required, so I have removed the wattmeter from the circuit diagram, and I have connected one test ammeter. So this VS is the standard voltmeter. Now this time AS is the standard ammeter, and this AT is the test ammeter. Right? All are secondary instruments, but these two are calibrated already, and now we are going to calibrate this ammeter. This is another secondary instrument that will be calibrated using this standard one. Okay, and the rest part of the circuit diagram will remain same. This is the load. is the variac, by varying of which will vary the supply voltage, and the supply current will be varying accordingly. This is the required data table that you need to draw in your notebook now, because after that I'll be showing you the few picture of the laboratory setups and the readings that you need to put over here. So please draw this observation table.
And the first one or second one?
What?
And
Number,
the first one or second one?
sorry, what we saying?
Ma'am, this observation table?
This is the observation table for both the
Yes, ma'am.
scales, for both the calibration. First column is number of observation. Second one is standard voltmeter VS reading in volts. Third one is standard ammeter AS in amps. Fourth is test ammeter AT in amps. Fifth is standard wattage WS, which is equals to product of AS and VS in watts. Then test wattmeter WT in watts. And finally, we calculate percentage error for both the instruments. One for the test ammeter, second for the test wattmeter. And here we need to consider MF. MF stands for multiplying factor of wattmeter. We'll see later on what is the significance of this multiplying factor. And you will calculate this percentage error for both these quantities, ampere and wattage, by using this relationship. Percentage error is equal to test minus standard by standard into 100. The numerator can be standard minus test also, but the denominator is always standard value. Okay, have you all drawn this observation table in your notebook?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And this apparatus table or equipments required. You will write down the name of the apparatus here in this apparatus table. So first you draw the table in the notebook, and here you will write the specifications and maker's table. These two will be provided by Nitu madam. So the items will be name of the items will be obtained from the circuit diagram. Actually, two tables are there. One is called device under test. Under this, you will write two names: one ammeter, test ammeter, and one test wattmeter. One number of ammeter, one number of wattmeter. And each table is equipments or instruments required to perform this experiment. Other than test ammeter and test wattmeter, what you will require to perform this experiment? You require a variac, standard voltmeter, standard ammeter, bulb load, right? These are the
Yes.
Yes,
instruments
ma'am.
required and a set of wares. So Ritu madam will help you to write the type
We have to draw two tables.
specification.
Device.
Yes, one is device under test. So under this you will write only two names. One is called test ammeter, one is called test wattmeter. And second table is equipments or instruments required. So under this you will write the name of the apparatus or instruments required. And what are the instruments required? Variac. Only one number of variac is required. The same variac will be used here for the calibration of ammeter. One standard voltmeter, one standard ammeter, and bulb load. Okay. Now,
And set of wires.
and set of wires, right? Cables or wires. And this is the mechanical switch which is already connected with the setup in the panel. Right? So one switch is also there. Okay.
Yes,
And
ma'am.
wattmeter contains two number of coils, as you can see from the diagram. One is called CC, the current coil, which is connected in between the two terminals M and L. That means this current coil is actually in series with the mains or line. And second coil, which is having more number of turns compared to the current coil, denoted as PC, means pressure coil, will be connected in parallel with the current coil or in parallel with the mains of the supply line, right? So always pressure coil, which determines the pressure or the voltage difference, will be having more number of turns, and the coil, the current coil, will be having lesser number of turns. Generally is connected in series with the lines because it's measuring the current, right? And this type of wattmeters are basically electrodynamometer type wattmeters that we use in case of AC circuit. They are basically constructed with unity power factor because there are low power factor type wattmeters also in our lab. In experiment number 6, probably we will use low power factor type wattmeter for the open circuit and short circuit test of transformer. So mainly all the wattmeters are designed with unity power factor. So this is that a type of wattmeter of electrodynamometer type whose power factor is unity. I hope you know the uh, basic definition of power factor because you have already studied power triangle, impedance triangle, so you know what is power factor, right? So
Yes, ma'am.
since these wattmeters are designed with unity power factor and it has got two coils, so one is measuring the current, one is measuring the voltage, and this instrument, this wattmeter will provide only the RMS values. So product of VRMS and IRMS will give you the value of power or wattage. Because cos phi here 1, the power factor is 1. So Vi cos phi is actually the true power or the active power in kilowatt or in watt that can be easily measured by this type of wattmeter. Fine. So here we'll take the two readings, Vs and As, right? So Vs and As in this fourth column. Uh, we'll get the value of standard or true wattage, true power or the input power, will provide the value of the measured power. Okay, now next coming to the experimental part. That's great. Okay, this is the setup that we have in our college lab, basic electrical lab, for this experiment, calibration of ammeter and wattmeter. You can see two voltmeters and two ammeters are mounted on this panel along with two switches and two bulbs. And this is the variac, single phase variac, and this one is the wattmeter. This is the wattmeter, right? So we need only one voltmeter, so we'll use this upper one, and we need two ammeters. One is the standard one, the upper one is the standard one, and lower one is the test one. Okay, and these are analog instruments, And analog instruments which are used in AC circuits are mainly called as moving iron type instruments. Can you see this sinusoidal symbol shown in this
Oh, yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
this sinusoidal symbol and also this symbol, like a resistance, the symbol of resistance. Can you see?
Yes, ma'am.
These
Yes, ma'am.
symbols are signifying that this is the AC meter, and which is of moving iron type, and this wattmeter is of electrodynamometer type. Okay. Now this is the nameplate of a wattmeter, electrodynamometer type wattmeter. It's a table mounted portable single phase wattmeter. Here, different voltage and current ratings are there, and based on these connections, like, can you see these four terminals, like B1, B2, B2?
Yes, ma'am.
These are basically strips. So
Yes, ma'am.
we can connect either B1, E2 and E1, B2, or we can connect only B1, B2. So as per the nameplate, this wattmeter will operate on 1 ampere current. That means the current coil will carry maximum 1 ampere current if we join B1 and B2. And if we join B1, E2 and E1, B2 simultaneously, then the same wattmeter will be operated for 2 ampere current. So nameplate is very, very important. Next, I'm going to tell you about the multiplying factor. See here, multiplying, there is a factor, multiplying factor given just below this connection. Can you see?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes,
Now,
ma'am.
now just look at this. These are basically the voltage terminals. This terminal. Okay? It has got a voltage terminal, a V terminal, right? So here three different range is given. One is 150, 300, 600. That means the voltmeter can operate till 600 volt, starting from 150. Okay, so here we'll use 300 volt for our application, for our use. We'll use 300. That's why you have connected this wattmeter at 300 volt with this rate wave, right? That means this is the V terminal of our circuit, this terminal. Okay, now with this 300 volt and 1 ampere, because we will not be able to follow the strip connection. So this is actually B1 and B2. See, the two strips are connected in between B1
Yes,
and
ma'am.
B2. It means that this wattmeter is now working on 1 ampere current, right? So 1 ampere you are sending to the current coil, and you have connected the wattmeter with 300 volts. So maximum watt is the amount of wattage that you can measure from this wattmeter. 300 into 1 equals to 300 wattage. 300 watt can be measured by using this wattmeter with these specifications, right?
Yes, ma'am.
Fine. All of you, please mute your microphone. Now, look at this table, multiplying factor table. Before that, let me show you the scale or span of the wattmeter. Just wait. Yes, this one. This is the scale or span of the wattmeter as shown at the top of the wattmeter. 0 to 150. This is the scale of this wattmeter. See, it can be used for both AC and DC. This is basically the advantage of electrodynamometer type instrument. Both these symbols are available. See, a sinusoidal symbol and this straight line or constant. This signifies that here voltage is constant, and this sinusoidal signal signifies that this can be used for AC circuit. Also 50 hertz is mentioned. One means unity power factor. There are many symbols that is mentioned at the top of this double mounted wattmeter, which will signify that this can be operated for both AC and DC circuits. That means it's electrodynamometer type wattmeter. But span is 0 to 150 watt.
Ma'am, the
Okay.
divisions are very close from 0 to the 30th mark and then 120 to 150 mark. The
Yes,
divisions are closer.
yes. This is the first division is 0 to 30 means 30 watt. 30 watt. After this is 30, that means this is 40, 50, 60. It means in between 30 and 40, only 5 divisions are there. Right? And here in between 0 and 30, this bigger one, bigger pointer is 10 and this is 20. Right? So 0, 10, 20 and then 30. And
Oh,
see,
yes, ma'am.
also in between 0 and 10, there are 5 divisions.
Here 26 watt is showing na, this value.
Which value?
Means watt meter is showing 26 watt
Why?
because needle is on 26 watt.
Middle means this is 60. This is 60, 70,
Means
80, 90.
Ma'am, he is telling the reading of the wattmeter now.
Okay, yes. The reading of the wattmeter is now showing at 10,
26.
then
26.
22, 4, 26. You are absolutely correct. Right. But what I'm
Ma'am,
trying to tell you, yes,
ma'am, but why there is a difference is line in between 0 and 30 and 32 then again till I think so that is 120.
150. 150.
120 to 150.
see when we
Yes, ma'am.
measure the power, the wattage value, we consider only the value of one small division. Like if it is 30 and if it is 60, and if in between we have two bigger intervals like one at 40 and one at 50, and between 30 and 45 divisions. So each division will be having two watts. So 32, 34, 36, 38, 40, like this. Right, and the type of these divisions between the intervals are basically the construction due to the type of the meter, right? So we'll measure only the based on the divisions in between the two bigger intervals, like in between 20, 30 or 30, 60, etc.
Yes, ma'am.
Not look into this type of divisions, why it is narrower at the beginning or why it is wider at the middle. We'll not look into that. We'll just measure, we'll just count the number of divisions between the two bigger intervals. Okay.
Yes, ma'am.
This is a
Ma'am,
specific.
ma'am, the difference is due to design also. Is anything that's
One cause is the design of this type of AC instrument or electrodynamometer type instruments. These are mainly design specific. Now look at the final value. It's 150. The range or the span of this scale. It's 150. That means this wattmeter can show you maximum 150 wattage. But as I have shown, I have connected 300 volt and 1 ampere. Right? I have connected 300 volt with this wattmeter, and this wattmeter is operated by 1 ampere because I have connected these two strips across the two terminals P1 and P2. And power factor is unity, so the total wattage can be measured by this wattmeter is 300, right? But the wattmeter is showing, wattmeter will show maximum 150 wattage. This is the maximum limit. So we need to go for multiplying factor. That means if you multiply the measured value, this wattmeter, with the multiplying factor, you will get the actual wattage based on the voltage and current values sent to the current coil and voltage coil. Like if the wattmeter is operated on 300 volt and 1 ampere, the multiplying factor is 2. Right? Multiplying factor
Yes,
will
ma'am.
be 2. Because you need to always multiply the reading
Times
as
2.
shown in the wattmeter by 2, because you have connected the voltage at 300 volt. Right? If you use
ma'am.
150 volt, multiplying factor is not required. It's 1, because 150 times 1 is 150 wattage, and the maximum span or scale of the wattmeter is 150. So you can easily measure till 150 watt. But if you're using 600 volt and 2 ampere, that means total wattage is actually 1200, right? But the span is only 150. So definitely you need to multiply that reading 150 as obtained from the wattmeter by a factor which is called multiplying factor, which is 8 here, right? In order to get the actual power. That means, what is the advantage of using this? You can measure high power like 300 into 1 300 watt, or 600 into 2 1200 watt, high power, high wattage, by using a small wattmeter. Why I'm saying that? Because here, see, the design or the cost, everything will depend upon the scale, the span of the wattmeter, right? If you can change the scale or span till 1200, so that you can measure up to 1200 volt. But in that case, your design will be a little bit complicated, the cost will be increased. There are many factors associated with the design of these instruments inside this box, right? So mainly cost will be increased. So that's why this is the advantage. If we use the multiplying factor, what we can do, we can measure high amount of power by using a small size wattmeter. And next is Variac. This is the Variac. This is the phase terminal, this is the neutral terminal, because it has got only 2 phases. It's a single phase Variac, and this will be connected with the supply. This is the top view of this Variac. This is the knob. See, initially it will be set at 0 when the circuit is just switched on, and after that you can vary this knob, and if you vary it, you will see the variation of the supply voltage from this voltmeter, which is connected in parallel with this Variac, this voltmeter.
Ma'am, what is the work of Variac?
Variac will be used to vary the supply voltage. See, this is an alternating supply voltage, AC supply voltage. That means it is not a constant voltage. Right? If it is constant, then it is not required to vary.
Through Variac, we can change the voltage.
We can change the voltage. Like the maximum voltage is 230. That means 0 to 230. this voltage can be varied by variation of this arrow because it's an auto transformer, right?
And we have, ma'am,
Transformer.
once we have used restate and variac both are same.
No, rheostat means variable resistance. Rheostat means variable resistance, right? And
Because
these two had the symbol.
restate also have same
Coil.
symbol.
Yes, symbols are same, but this is the symbol of a coil. See, it has got many turns. It's just like a transformer, which is called auto transformer. So it works on transformer mainly, right?
Okay, ma'am.
Right, in transformer there are two separate windings called as primary and secondary. But here actually in auto transformer, the secondary windings are superimposed on the primary windings. So that I'll discuss later on in the theoretical classes while I'll explain the principle of auto transformer. But this is mainly used to vary this AC supply voltage. Okay, and by varying this knob, you will be able to vary the supply voltage. But here, different markings are there, starting from 0 to 260. But here, this 20 marking over here, it does not signify that it refers to 20 volt. It may be higher than 20 volt or maybe lesser than 20 volt. And 80 marking does not signify that if the knob is here exactly at 80, you may not observe exact 80 volt from this voltmeter.
Ma'am, where is the knob of the variac? I can't see.
This one. This is the knob. This black colored circle. This is the
No,
knob.
ma'am, which one? What is the point it is pointing at?
Now it is pointing in between, say near about 210,
210, 212.
Oh, okay.
212, 212. But at this position may not be, you will get exactly 212 from this voltmeter. Because these, the span of this voltmeter and the span of this variac are not synchronized. This is only used to vary the supply voltage. Okay. I'll show you the experimental readings one by one, but before that, you just have a look on these two videos, small videos, which shows the how to perform the experiment.
এই যে ঘোরাচ্ছি ইনক্রিজ করছি ভোল্টেজ
See, by variation of this knob of this variac, variable readings are shown from these instruments. The pointer is also varying in this meter, or also in case of these 2 wattmeters, right? And the intensity of bulb is also are also changing accordingly. Both these bulbs are connected in parallel. Internally, they are connected in parallel. In the circuit diagram, what I have shown you earlier, only one bulb was drawn, but actually here we have taken 2 bulbs in parallel.
এতে ওরা বুঝতে পারবে না যে ভোল্টেজটা বাড়ছে কাকে দিয়ে বাড়াচ্ছে phase 2 wattmeter main load in into ammeter আমাদের সিরিজ Submitted to load and load. Then Bluetooth that's neutral. Wattmeter voltage coil of Fisher Price. Neutral. One connected, neutral, and phase.
Okay. So after the connection diagram, what we'll do, we'll vary the variac and we'll take the readings. So first, we'll take the readings of the standard ammeter and test ammeter. As I said, upper one is the standard ammeter and lower one is the test one. So suppose this is the first reading of the supply voltage. First note down what is the value of this supply voltage. This is 100, this is 200. So 100,
I think it is 120.
120, 130, 140, because this one is the middle one, 150. So this is 110. So in your data table, first you will write here 120. Next, we'll take the reading of standard ammeter and test.
Ma'am, 120 or 110?
Just wait. 20. This is 110. This is 120. 30, 40. This is 150. 160, 170, 180, 190, 200.
Yes, ma'am.
Right?
Yes, ma'am.
So at this moment, what are the values of, this is the standard ammeter. This is 0.4, this is 0.6, this is 0.5,
Ma'am, 0.41.
0.41. This is 0.42, 0.3, 0.5.
Ma'am, 0.43.
0.4.
0.43.
Right. This is 0.5, right? So
Ma'am, each of 0.02.
6,
Yes, ma'am.
8. So, yes, it's in between 0.42 and 0.44. Okay.
It is a bit closer to 0.42.
Yes. You take approximately this one is 0.43. Okay, standard one. What about the test one? This is the test ammeter. So it's just point
442.
0.44.
0.42.
42 or 44?
4 ma'am.
4 4.
You please note down all these readings in your notebook. 0.44. That means for this particular reading, you can measure this WS using calculator. S times Vs, which is the standard wattage. And then you can calculate this percentage error for test ammeter, which is just true minus measured by true into 100. True means standard. So standard minus measured, the test, by standard into 100. That is the percentage error. So you can calculate percentage error, and here you will write multiplying factor as 2. We'll mention multiplying factor used here 2. Okay, because we have used 300 volt and 1 ampere current. So it is 300 in total, but the span is 150 only. So we'll use multiplying factor as to 2. Okay. For the next reading, for the next observation, measure the supply voltage.
One 180,
140. 140.
140,
140, yes.
How much?
180,
140, ma'am. 140.
And 140.
140.
140, right. So please write supply voltage is 140. Next, standard ammeter, standard ampere reading.
0.47.
0.47.
47. 0.47.
47 or in between 47 and 48.
475.
Right, 4.475. Right. Okay. Actually, it is at 0.47, right? If you look from the top, you will see exactly 0.47. But since we are observing all these readings virtually, we are observing only the screenshot, right? That's why little bit of error we have to consider, because but it is actually at 0.47. If you look from the top, you will see the pointer is exactly at 0.47. But leave it. You just note down the value what you are observing virtually from this window. Okay. So next one is the,
Ma'am, 0.475 then.
yes, now it is 0.475 as per this screenshot.
Ma'am, then the last one would be 0.425. It was just above 0.42.
This one.
No, ma'am, for the first reading, the first 120 volt.
This one.
Yes,
This
ma'am.
one you consider 120. Pointer is exactly.
No, ma'am. The standard ammeter value.
rating.
This one.
Yes, ma'am.
Yes, ma'am.
0.425. Okay. You consider 0.425. We have considered 0.43. This is 0.42. This is 0.44. So middle one is 0.43. We have taken 0.43.
Okay, ma'am.
And this is exactly 0.44. Its small deviation is 0.2. 0.02. Okay. This is the test ammeter for the second reading. 0.4.
8.
8. Right.
0.48.
0.48. 0.48. So this is 0.48. This is
475.
0.475. And this voltage is
140.
140.
140.
good. Next, third reading.
Ma'am, we have to multiply test watt meter means standard wattage with 2
I
to get
haven't
test
shown,
watt meter.
I haven't shown the wattmeter reading yet. I'll show you the wattmeter readings later.
Okay, ma'am.
Then you will multiply.
160.
160.
160.
Supply voltage 160. Standard ampere
5.1.
Point fi- 0.51.
Oh,
Five-
0.51.
0.51.
0.51.
right. Test ammeter.
A 0.51 almost again.
Yes, 0.51. 160. Both are at 0.51.
It was little shifted from 0.51.
Very small
Point-
deviations.
0.515 can we take?
Which one? This one?
Yes, ma'am.
This is 0.5. This is 0.52, 0.515. 0.51. Yes, you can take. You can take 0.515, but according to me, both are 0.51. Very small deviation that we cannot measure from this screenshot.
Okay, ma'am.
Okay, ma'am.
Next one.
180.
Yes.
180.
For 180 volt.
Point 0.55.
0.54.
This is 0.54.
Um,
6 in between 5.4 and 5.6. The standard one.
5.545.
4.5.
Closer to
0.545.
0.5.
Test one is exactly 0.54. Test one, 0.54. But standard one is a little bit shifted from
5.5.
545. Take 0.545. $200.
200.
0.58.
0.58.
Point
0.58.
58.
0.58.
58.
No, ma'am,
0.57.
Oh, 57.
57.
Ma'am, 0.578.
Which one? Test one. This is 0.8.
Yes, ma'am.
0.58. It is lower than 0.58. In
No,
between
I'm telling ma'am 0.578.
0.57.
This one is 0.557.
0.52468. In between 0.56 and 0.58.
0.57.
0.57. So approximately you just take 0.57. As you are increasing the supply value, supply voltage, see, the current values are also increasing. Now, wattmeter readings.
Ma'am, this was the first one.
First one, first reading.
28.
28. 26.
10, 20,
Yeah. 26.
2, 4, 6.
26.
Right.
Ma'am, this one will be standard or tested?
test 1. 26 into 2. Actually, it is 52. It's not 26, it's 52 because we have to consider the multiplying factor. That should be multiplied with this wattmeter reading because we have connected the V terminal with 300 volt. Next, for second reading, it is
34.
34 into 2.
34.
yes,
68.
yes. Next, for third reading, it is
42.
42.
42.
42.
42.
Next,
50.
50.
50.
right. This is
68.5.
58.
59.
58. 59.
58.
58.55.
consider 59.
58.85.
Yes, so consider 59. Now calculate this standard wattage, that is just product of VS and IS, VS and AS, and then calculate the percentage error. And below this data table, observation table, you will show one sample calculation for any one reading, one for test ammeter and one for test wattmeter, and below of which will mention, will write the conclusion.
Will you repeat?
How to write the report? First, you will write experiment number, then title, objective. After that, you will draw this apparatus table, the two apparatus tables. Then you will draw these two circuit diagrams. Below the circuit diagrams, you will draw this observation table. Below the observation table, you will show one sample calculation using this formula, one for test ammeter, one for test wattmeter. And finally, you will write the conclusion of this experiment.
And what is PO and that one?
No, you don't need to write these two. No, you don't require to write P and Saturn.
In percentage error, we have to show only one reading. Means
Yes,
below.
one for ammeter, just below the observation table.
Okay.
Will show that for reading 1, the percentage error for test ammeter is this 0.43 minus 0.44 by 0.43 into 100. And suppose for reading 5, the percentage error for test wattmeter is the standard power, this value WS minus WT, the measured power divided by the standard power into 100. Right?
Okay,
And
ma'am.
Okay.
after that, you will draw the graph, percentage error in the millimeter graph paper. Percentage error versus ET is standard. and then percentage error versus WS, standard method. We'll draw only a line graph. Maybe a positive error, it may be a negative error, like that. I've drawn this graph arbitrarily. Okay. In the millimeter graph paper, we will draw the percentage error versus the true readings. One for ammeter, one for wattmeter.
Ma'am, the graph will be the straight line.
Yes, line bar graph, not bar actually, line graph. Line graph. Suppose this is for standard ammeter. The first reading is 0.43. So at 0.43, what is the percentage error? Can anyone tell me at 0.43? Standard ampere, what is the value of percentage error?
Ma'am, 2.2 minus.
If you take the mod value, you will only get the positive errors. Yes, point
Oh,
0.01 by 0.43 into 100.
1.
Exactly 1.
no, ma'am, 2.2.
2.32.
2.32.
2.33.
0.43 minus 0.44 equals to divided by
2.32.
3 right, into 100.
I'm 2.27.
2.325
Yes,
minus
ma'am.
Oh,
3.
ma'am, we will write minus.
Yes, you will write minus, and here exactly at 0.43 we'll draw a line whose magnitude is 2.32. This magnitude. Right? Similarly, you calculate the percentage error for the second reading. 0.47. Here also the standard value is lesser than the test value, so we'll get a negative error. 0.475 minus 0.48 equals to divided by 0.475 into 100. So it's 1.05 minus 1.05.
Minus 1.05.
Okay. So similarly, you will find out all the percentage errors for wattmeter readings.
Ma'am, for the third one, it will be 0 error.
0, definitely. Third one, the error is 0.
Ma'am, for second one, it would be positive error.
Right. Standard value is 0.475, which is lesser than the test value.
तो मैम टेस्टिंग माइनस स्टैंडर्ड है ना तो
No,
ज्यादा ही होना चाहिए.
I am taking standard minus test. As I
Ma'am, I am
said,
getting 0.775.
see, percentage error can be either true minus Right, standard minus test by standard. I'm taking this one, standard minus test for the first two. Or you can consider true minus test minus standard by standard. Both are correct.
But ma'am, the units
Ma'am,
will be
standard
different.
minus test by standard is fine. Ma'am, test minus standard by test it would be.
No. Denominator will be always the standard one.
Then
Numerator,
ma'am, the signs would be
Ma'am,
different.
yes, ma'am.
In positive, I am getting, ma'am, plus 0.77.
for which one?
For test watt meter, percentage error, 0.77.
Test wattmeter.
Percentage error, ma'am.
For the first reading,
Percentage error means for standard wattage, I am getting 51.6.
just 120 into 0.43.
Yes,
Yes,
ma'am.
ma'am. 51.
51.6.
Yes. And the measured one is 52. Measured one is 52.
Yes, ma'am.
Yes,
52
ma'am.
minus 51.6 into 100.
So true minus measured by true. So 51.6 minus 52 by 51.6 into 100 is the percentage error.
Ma'am, 0.775.
7-8.
Okay. So complete this observation table. And do you have any more questions from experiment 3? If you have any doubts, any queries, you can ask me.
No, ma'am.
So, madam, are you there?
Yes.
Okay. Neetu madam, you can now help them to write the apparatus table.
Okay.
Discuss about the ratings and the quantities, types, etc. Okay. And after that, it will take the attendance. Okay.
Okay, now you write down device under test. First name of the device is test wattmeter. Quantity is 1. Type is electrodynamometer type. Electrodynamometer type. Rating is 1/2 ampere, 1/2 ampere, 1/2A, comma 150/300/600 volt, and the scale is 0 to 150 watt W. Completed?
Can you repeat that, ma'am? Rating.
Yes. 1/2 ampere means 1/2 ampere. If it is connected, that strip is connected. If it is connected in series, then the current will draw is 1 ampere, and if it is connected in parallel, then the total current draw is 2 ampere. That is why 1/2 ampere, comma 3 voltages are there, 150/300/600 volt. You had seen the wattmeter, na? 3 voltages, madam had shown you 3
Yes, ma'am.
voltages.
Yes, ma'am. Yes,
That is why that thing is the rating. 1/2 ampere, comma 150/300/600 volt, and scale is 0 to 150 watt, means 0/150 watt W. Completed?
Yes, ma'am.
Yes, ma'am.
Maker's name is AE, capital A, capital E, Automatic Electric. You can write AE just. Next one is test ammeter. Quantity is 1. Type is analog moving iron type. Analog moving iron. Rating is 0 to 1 ampere. Zero to 1 ampere. Maker's name is AE. Capital A, capital E, that is automatic electric. Completed?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Go to next table, that is equipments or apparatus table. Okay, first apparatus is your voltmeter. Quantity 1. Type is analog moving iron. Range is 0 to 300. 0 dash 300 volt. It's starting from 0 and the final reading is 300. 0 dash 300 volt. And maker's name is again AE, capital A, capital E. Next one is the ammeter. Quantity 1. Type analog moving iron. Range 0 dash 1 ampere, 0 to 1 ampere. Maker's name same AE. Maker's name is AE, automatic electric. Okay, you can write just AE. Next is Variac, VARIAC. VARIAC, Variac. Quantity is 1. Completed?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Type of the Variac is auto transformer. Auto transformer. And the range is 2 ampere, 0 to 240 volt. 0 dash 240 volt. Starting from 0 end is 240 volt. You can vary up to 240 volt. And the maker's name is Cosmo, COSMO, Cosmo. COSMO, Cosmo.
Ma'am, all caps.
No, small letters. Capital C is only capital.
Okay, ma'am.
COS. C is capital. OSMO, Cosmo. Next is your load. Next apparatus is load, that is in bracket, right, lamp. Load is your lamp. Write down
Lamp.
load in bracket lamp. Yes. Yes, what happened?
Nothing.
Renita Sen. Nothing. Okay. Okay, load is load, LOAD, load in bracket lamp, LAMP, lamp. We are using lamp as a load, okay? So
Okay, ma'am.
quantity is 1 and your type is tungsten filament. Tungsten filament. Tungsten, you know about tungsten filament, na?
Yes, ma'am.
Yes, ma'am.
Yes,
Earlier,
ma'am.
earlier we are using that type of lamp only. Nowadays, all various types of LEDs are there. Tungsten filament. And the range is 100 watt. 100 watt. Maker's name is Philips.
Ma'am, for lamp quantity should be 2 na.
Yes, yes, you can write 2.
Ma'am, you have told 1.
Yes, yes, yes. You are using here 2 lamps. Completed. Range is
Yes,
100
ma'am.
watt. Dealer's name is Philips.
Yes, ma'am.
So completed all the tables.
Yes, ma'am.
Now
Yes,
you give your attendance. Okay, give your attendance. Wait. Tejas Advik,
Present, ma'am.
why you are not submitting the that your classroom work, that your assignment work, all the practicals? Tejas,
Ma'am, I will submit it today.
you have not submitted XN 1, XN 2, XN 4, XN 10, only submitted XN 5. Why? Okay, you submit all the experiments.
Okay.
Marmik Agrawal,
Present, ma'am.
Marmik, you had not submitted XN 1. Okay?
Ma'am, that capacitor one.
Yes, that XN 1, that capacitor resistance, that one.
Okay, ma'am. I will submit it today.
Okay, fine. Next is your Farhan Ahmad,
Present, ma'am.
Lisan Ali,
Present, ma'am.
Lisan also, same thing, I think. Farhan Ahmad is okay. Lisan not
Ma'am, I
submitted.
will submit the lab by today, ma'am.
Lisan not submitted experiment 2, 4, 5. 3 experiment
Yes,
not
ma'am.
submitted still, okay? Check whether
Yes, ma'am.
it
I
has
will
been-
submit it by today.
Okay, okay. Aditya Banerjee,
Present, ma'am.
Riddhi Banerjee,
Present, ma'am.
Shubhranil Banerjee,
Present, ma'am.
Abrajit Basak,
Present, ma'am.
Shoham Basu,
Present, ma'am.
Pindu Bera,
Present, ma'am.
Ritoja Bhaduri,
Present, ma'am.
Rito Cheta Bhaduri, okay.
Present, ma'am.
Sorry, huh?
It's okay.
Rito Cheta Bhaduri. Next is Sattam Bhattacharya. He's always absent. Okay. Let me check the evaluation sheet. After Lisan Ali, all are okay. Next is Sattam Bhattacharya. He's absent. Okay. Aviroop.
Present, ma'am.
Aviroop present. Wait, we are having the problem. Aviroop. Aviroop, you had not submitted experiment 1, experiment 5. Okay?
Yeah, ma'am. I'm aware of that.
Okay. Shagnik Vishwas,
Present, ma'am.
Abhir Chakraborty,
Present, ma'am.
Oindrila Chakraborty,
Yes, ma'am.
Ankita,
Present, ma'am.
present. Your surname is very tough, I think. Okay. So I'm calling you. Okay. Abdi Das, absent. Chandrani Das Sharma,
Present, ma'am.
Mouli Dev,
Present, ma'am.
Anushrita De, absent. Showman Digar,
Present, ma'am.
Shahib Al Farasat,
Yes, ma'am.
Shivab Al Farasat, na? Okay.
I'm Sihab.
Shihab, yes.
Yes,
Present.
ma'am.
Okay, next is Shagnik Ghoshal,
Present, ma'am.
Aditya Ghosh,
Present, ma'am.
Aditya is present.
Yes.
Aninda Ghosh,
Present, ma'am.
Aman
Present,
Aman
ma'am.
Gupta, present. Apurva Krishna Jha.
Present, ma'am.
Okay, next is Harsh Ranjan Jha.
Yes, ma'am.
Sangeeta Jha.
Present, ma'am.
After Abhiroop, next is Chandrani. You have not submitted experiment 2. Okay. Chandrani, are you there? Chandrani Das Sharma. Is she absent?
No, ma'am. She left. I think there is a connection problem. Network connection.
Harsh Ranjan Jha. You have not submitted 2 experiments. Sangeeta Jha. Next. Not
Ma'am,
experiment
sorry,
3.
I was having network problems.
Okay.
Ma'am, this is Chandrani.
Okay, Chandrani, you had not submitted experiment 2. Okay.
Okay, ma'am, I will submit it.
And Sangeeta Jha also not submitted 3 experiment. Next is Shantanu Kappas.
Yes, ma'am.
Mohammad Zain Khan.
Present, ma'am.
Farzina Khatun.
Present, ma'am.
Shohil Kole.
Present, ma'am.
Arun Kumar.
Yes, ma'am.
Prince Kumar.
Present, ma'am.
Pooja Kumari.
Present, ma'am.
Pooja Kumari present. Okay. Arun Kumar also not submitted 1 experiment. Okay. Pooja Kumari 2 experiment 1 and
Yes, ma'am. Experiment number 7.
1 and 4. Pooja Kumari 1
Ma'am,
and
I
4.
submitted all the experiment.
Pooja Kumari.
Yes, ma'am.
Wait. Pooja Kumari not submitted experiment 1, experiment 4. Okay. Pooja Kumari, you had not submitted experiment 1, experiment 4. So you please send again. Okay.
Ma'am, I
Okay,
have
ma'am.
joined late, so I don't know what to write in first experiment.
Who is there? Arun Kumar?
Yes, ma'am.
Okay.
Experiment number 1.
Then you leave that experiment.
Okay, ma'am.
Next is your Aishi Kundu.
Present, ma'am.
Aishi Kundu is present, na?
No, Ishikundu is present.
Yes. Next is Shagnik Mukherjee.
Present,
Shagnik
ma'am.
Mukherjee present. Shagnik, I think, wait, this is your second attendance, na? Shagnik Mukherjee?
Yes, ma'am.
Okay, but you had not submitted 1 and 2, I think. Yes, 1 and 2.
Yes, ma'am. I'll submit it.
Okay. Rifa Akhtar Malik.
Present, ma'am.
Iladri Ranjan Pal.
Present, ma'am.
Agradeep Pani.
Present, ma'am.
Rinal Patra.
Present, ma'am.
Shaurik Poddar.
Present, ma'am.
Shaurik Poddar. Atul Raj.
Present, ma'am.
Ilhan Raza. Shomi Shamanta.
Present, ma'am.
Kirti Sharaf.
Present, ma'am.
Vojit Shau.
Present, ma'am.
Rinita Sen.
Yes, ma'am.
Kundan Sharma.
Present, ma'am.
Raj Singh.
Present, ma'am.
Bhavna Sinha Roy.
Present, ma'am.
Shrajal Srivastav.
Present, ma'am.
Pratik Tiwari.
Present, ma'am.
Completed. And after Shagnik, Ahuna Sinha Roy not submitted only 1 experiment, that is experiment 4.
Ma'am, I'll submit it today.
Okay, fine. Okay, rest all are okay. Okay, now you can leave.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you, ma'am.
Thank you, ma'am.